Graphs of functions. We can make graphs of functions several ways. This section we're going to mostly be making graphs by making tables. And the instructions for this first problem say sketch the graph of the function by first making a table of values, and then the given function is f of x equals x squared plus 3. So I've set up a table, and just so that we all have the same answers, for your homework, for x values, use -2, -1, 0, 1, and 2. Then the function goes at the top of your table, and you're going to plug in these x values one at a time into the function, work them out, and then you'll get the y values. So we have 5 points to plot to make our function, and we'll do that on this graph. It's x and y. So we've got -2, 7. Have to go up above the grid just a little bit. So there's -2, 7, -1, 4, 0, 3, 1, 4, and 2, 7. And then connect your dots, and it's a parabola, which it should be since it's an x squared. And we have our graph. So for the x values, use -2, -1, 0, 1, and 2. Now, there's a special kind of graph, a piecewise function, and the piecewise function will be more specific about what we need to use in our table for the x values. There's more than one correct way to graph these. Some people can do them without making a table. If you can and you're getting them correct, that's fine. But it helps with accuracy if you make a table. The function is in 2 pieces, so we'll be making 2 tables. And I'll start with the table for when f of x equals 3. So here's x, and then the 3 is the function, and y. And I need to figure out what I need to fill in the x column. Well, it says x less than 2. So 2 is our starting value. Now, because it says less than and does not have the equal to, at my starting value, I'll need an open circle. It still needs to be a 2 there, even though it doesn't have the equal to, but it will be an open circle. Less than 2 means I need to pick a couple of numbers that are less than 2 to fill in for x, so I'll just choose 1 and 0. Now, normally, you take the x values you've chosen, plug them in for x in the function, and get the y value. But there is no x for this function, it's just a 3. So all of the y values are 3. Now let's make a table for the part that says x minus 1. Again, my starting value is 2, but because it has the equal to, I know it's going to be a closed circle. It's only the starting values that you have to worry about open or closed circles. All your other points will be closed, but the starting value could be open or closed, depending on if it has the equal to or not. Greater than 2, so I pick a couple of numbers bigger than 2. Plug those in for x. So 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. Now let's plot our points. For the first table, 2, 3 is an open circle, and that's my starting point. 1, 3, and 0, 3. When you connect these, you'll only have an arrow coming out of one side because it's less than. That means I go to the left forever. Then I'm going to do the second table, and my points are 2, 1, and that's closed, 3, 2, and 4, 3. It's a greater than, so I know I need to go to the right. This one was to the left. Sometimes you'll have points overlap each other, and that's fine, and sometimes it's completely disconnected, like this one is. So it's a piecewise function. The graph is in pieces. Let's try another one. This one is in 3 pieces. So we'll make 3 tables. For the first table, the function is -2, and x is less than 0. So 0 is my starting point, and because it does not have the equal to, I know it will be an open circle. So a couple of numbers less than 0, let's do -1 and -2. I don't have an x to plug into, so all of my y's will be -2. The second function is just x. Now, the values for x are a little bit different. Not only do I have a start number, I also have a stop number. So my start number is 0. My stop number is 2. The 0 has an equal to, so I know it will be closed. But the stop number, the 2, does not have an equal to, so it will be open. And then I need to pick a number in between 0 and 2, so let's pick 1. Sometimes you have to do a fraction for that in-between number. When I plug in for x, I don't have anything to do with it. Once it's plugged in, that's going to be the value. So 0 plugged in gives me 0, 1 gives me 1, 2 gives me 2. Then the third table, the function is 2. X is greater than or equal to 2, so 2 is my start number. It has the equal to, so I know it's solid. A couple of numbers bigger than 2, let's do 3 and 4. Again, there's no x to plug in for, so all of the y's are 2. Now let's graph from our 3 tables. The first table, 0, -2, is open. -1, -2, -2, -2. It's a less than, so I know my arrow is going to go to the left. Then the middle table, 0, 0 is solid. 1, 1. 2, 2 is open. Because the x is trapped in between 0 and 2, then my graph is going to be trapped in between. There won't be any arrows coming out at all. The third table, 2, 2. I already have a dot at 2, 2, which is open. But from the third table, 2, 2 is closed. So it's just going to fill that in. And then 3, 2. And, whoops, that shouldn't be there. 3, 2. And 4, 2. It's a greater than, so that arrow goes to the right. Finally, we can determine if the graph of an expression represents a function or not by using the vertical line test. Vertical means straight up and down, and you can use your pencil as your vertical line. A formula is a function if for each x, which is the input, there's only one y, which is the output. So if I look on the graph, this first graph, for example, when x is 2, there are 2 y values that go with that. So because there's more than one outcome for my x, it is not a function. The vertical line test is a visual way to see this. If you pass a vertical line across the graph and it touches the graph in more than one spot at a time, it's not a function. So this first graph is not a function. The second graph, if you pass a vertical line across, it will only touch the graph at one place at a time. For every x, there's only one y. So this one is a function. And there are several more examples in your book that you can look at for that.